Okay, 6th grade, our objective is to continue talking about those fun polygons. Guys are okay. We are going to move on to 10.3, which is area and perimeter of 4 different figures. So we're going to talk a lot about that today. Homework should be in the practice packet tonight. I think we're moving away from the book. I know you guys are happy about that. There is a quiz. I'm going to just remind you again, there's a quiz in this chapter after lesson 10.4. So we're just doing 10.3 today. I'm thinking the quiz will be next Wednesday, possibly, but I'll let you know tomorrow. I want to see how you guys do today. So just keep in mind there is a quiz coming up, and then after that, there will not be a test until the end of the chapter, which will be on the entire chapter 10. Okay? Any comments on what you think about the chapter so far? Easy? Doug? Bad at shapes? Okay, well, we're going to try to work on that today with the flow chart that I gave you. Mary? Okay, we're going to work on that. Annalise? We're going to work on more of that today. Okay, so let me start with part of your warm-up was checking homework because I didn't want it to take too long, so I could just spend time answering questions. So, Mary, what questions do you have? Okay, number 12. Do you have your book in front of you? No. Okay, look at my number 12. Okay. What on number 12 tells you that it has to be a square? Yes. Can't be a rectangle because the most specific name for number 12 is a square because all the sides are congruent, all the angles are right angles. What other one, Mary? Okay, 13 is not a rhombus because a rhombus, all sides are congruent. That one only has opposite sides are parallel. So for a rhombus, you have to have all the sides are congruent, but we know in a rhombus that we don't really care about the angles. We just want all the sides to be congruent.
So a rhombus is just like a square.
Yep. Does that help you? Okay. Anything else for now? Do you have something else, Mary? Go ahead. Go ahead. Okay, you need to set up 22. So do you have your initial equation written down? That's why. There's 4 angles. Okay, so you should have 2x plus 2x plus 1x plus 1x. There's not 2 angles in the trapezoid, there's 4. And let me just show you my picture. By this picture, these are congruent and these are congruent. So 2 of them are x, 2 of them are 2x. Got it? Okay. Alyssa. Okay, I'm going to save that one just because that's the challenge problem. Is there anything else besides 24? I'm going to do it, just not right this second. Annalise? Okay, 15 says a square is blank a rhombus. Okay, a square is always a rhombus because a rhombus has congruent sides. So just like a square is always a rectangle, a square is always a rhombus. Listen to what it's not saying a rhombus is always a square. It's saying a square is always a rhombus. A rhombus can have 90-degree angles, but it doesn't have to. In other words, a square can be categorized as a rhombus because all the sides are congruent. It's kind of like saying a square is always a rectangle. Yeah. Doesn't matter. A square can always be a rhombus is all they're saying. Right, but a rhombus is not always a square. You're thinking of the opposite, Annalise. A rhombus is not always a square. A rhombus is sometimes a square, but a square is always a rhombus. The only thing we care about in a rhombus is all the sides are congruent, okay? The angles are going to be something, but we don't know. You were thinking of the opposite. That's why you were confused. Yeah, but that doesn't matter. A square always has 90-degree angles. A square is always a rhombus. A square can always be categorized as a rhombus because a square has all congruent sides and right angles. A rhombus only has congruent sides. It's just like the saying, a square is a rectangle. Do you understand the saying, a square is a rectangle? Okay, it's the same thing, but with a rhombus. Go ahead, do you have another one? What number did you say? Yeah, 15's always. They're up on the board, Annalise, don't forget. Okay. 16 is sometimes, and I just explained that one too, because it says a rhombus is sometimes a square. Who can tell us why a rhombus is sometimes a square? Emma H? So a rhombus, the only time that a rhombus is a square is when all the sides are congruent and it has 90-degree angles. So a rhombus is sometimes a square. No, they could. And then you said 17 too? Okay, 18, I'm thinking you forgot the 90 degrees. On 18, you need to add up 59 plus 2x minus 17 plus x plus 90 equals 360. Because there's 4 angles. So on the picture, one of the angles has a box. That means it's 90 degrees. Okay, you can't forget about that. You okay? Okay, Mary? I'll get to that in a couple minutes. Let me finish up the questions here. I'll just give you my answer key. Emma? 17. Okay, 17 is a trapezoid, is blank a parallelogram. 17 is never. Why is a trapezoid never a parallelogram? Justin, why? Good job. A trapezoid only has, like Sean was at, I think this was Sean telling me earlier, asking me, trapezoid only has one set of parallel sides, but a parallelogram has to have 2. Why? That's why it's called a parallelogram. Is that okay?
Yeah.
Okay. Jeremy? We're going to talk about that in a minute, so hold that thought. Don't ask me about this. I'm getting to this. Okay? Hold on. You guys are ahead of me. Anyone else on the homework? Annalise. 59 plus x plus 2x minus 17 plus 90 equals 360. And I'm getting to 24. Just want to make sure there's nothing else. Okay, let me draw 24 up here so we can kind of talk through it. The polygon flow chart will help you guys with types of polygons and what is always what, like those things you had to fill in on your homework. Okay, so let me draw this real quick. Okay, so you guys know W, X, Y, Z. Okay, this is not perfect, but it works for now. All right, so you need to find W, X, Y, and you need to find X, Y, Z. So let's start with like the common sense stuff here. So those of you that got this, what could you fill in based on what it looks like now? Briar, what can you fill in? Good, so tell me what this one is right here. Okay, well you could tell me though. I think you should be able to tell me. This is 90, this is 45. Close. You can use your calculator if you need to. 45, Briar, plus what is 90? No, this one right here, this little one. There you go. Okay, so this little one up here, it's 45 degrees. Okay, what else do we know just by looking at it, Doug? Awesome. So these have to be 90. What else do we know just by looking at it, Justin? You said that this is the same as this? I disagree. What'd you say? Are you talking about this? Yeah, these have to be the same. So you're right. I'm sorry. Maybe I misunderstood you. Emma H? Good. This has to be 30 degrees because it's a 30, 60, 90 triangle. Triangles have 180 degrees. Charles? Good. Why? Okay, there's another reason, but that's a good reason. But that works. Or Donatus, what else? mean, we're going to show that in a second. Can you explain to me why else you know that these are both 90? Awesome. That's what I wanted. Throwing some algebra in here. Thanks, Donatus. So if these are the same, we learned the other day the sum of interior angles. What's the formula for sum of interior angles, Alyssa? Well, what's the formula we use? I know that this one has 360, but for any polygon, what formula do we use for inside angles? There's an n in it.
Oh, and -2.
Good. So I know we don't need this for a quadrilateral. Notes for anything, any kind of polygon. I'm just bringing it back so you guys remember. But Donatus brought up what I wanted you guys to. If these are both x, 2x plus 90 plus 90 equals 360. If you solve that, you know each of these are 90 degrees. So they ask you to find WXY. So angle WXY is right here. What is angle WXY? Briar? Good, 135 degrees. They also ask you to find angle XYZ, which is XYZ, which is right here. What is angle XYZ, Sean? Good, it's 120 degrees. So if you kind of just go through process of elimination like we did, use your common sense, find the missing angles that you can based on what you know, because technically all of you guys knew enough to solve this. I'm guessing some of you just did not know where to start, and I know it was a challenge problem, but really, you guys are all smart enough to figure out these, and then, all right, based on what they gave you here, you can find the missing angles. This is definitely a geometry problem, so you will get to this in 2 years. Mary? What angles? These ones? We found a lot of angles. Okay, 45 plus 90 is 135. 90 plus 30 is 120. This thing, that means they're congruent. Remember when we did that at the beginning of the year? If it's like a curved edge, that means the angles are congruent. Okay, Annalise? You can't do that. I don't know either. I would just forget about what you did because it's not right, and just the way we did it is the best way to do this. Okay? Yep. Okay, anyone else on any of the homework, anything that you need me to go back to? All right, let's go to Mary. Oh, yeah, sorry. I knew I'd forget. Okay, let's go to the flow chart. 21 is in, I think the book writes it in there. I'm going to go to the quadrilateral flow chart first. Oh, that was quick. You good? Okay. All right, so who can tell me what goes up here? Let's start here. Annalise? No.
Wait, where?
Right here. At the very, very top. What goes at the very, very top? Charles? Yep. Quadrilateral. Okay, these are all types of quadrilaterals. So that's the very, very top, because everything here is going to have 4 sides. Okay, let's go here. Zach, what goes here? Good. Parallelogram. If you have them wrong, fix them. This is a good flow chart for you. Mary? I'll get to that. Let me keep going, then I'll get to that, I promise. Put it on my desk. If you're not done, just put ND on it. Yeah. If you guys aren't done, you need to see me later today, 9th grade. Okay, so parallelograms here. Alyssa, what do you think goes here? Good. Rectangle. Okay, let's go over here. What do you think goes here? Justin? Good. Trapezoid. Okay, let's go here. What goes here, Emma H? Good. Kite. Okay, let's go here. What goes here, Mary? Good. Rhombus. Briar, what goes here? Good. Square. Oh, no, you're good. Do you need me? Yeah. No, you're fine. Yeah, they have them.
Okay.
He gave them both packets last week. No.
Okay.
So that's okay. After the recording, they have them. And I don't know if he left you an answer key, but I can bring you one later if you need it. Okay.
All right, thanks.
So yeah, sure. Sorry, guys. Okay. First question. Raise your hand if you had this all right, 6th grade. Charles, quick. Raise your hand if you had this whole thing right. Okay. Who can now explain to us why is quadrilateral up here, but parallelograms here? There is a very important reason. Sean, why? Okay, so explain why that's important. Why not? It's very important that you guys remember, in this flow chart, everything is a quadrilateral because everything has 4 sides. Jeremy, you okay? Do you need to go to the bathroom? Do you need to go to the nurse? If you feel like you're going to get sick, go to the nurse, please. Okay? Okay. A parallelogram is not up here because a trapezoid and a kite do not have 2 sets of parallel sides. However, all this stuff under here does have 2 sets of parallel sides. So here's our ways we can classify as a parallelogram. This also tells us why a square is always a rhombus, a square is always a rectangle. Okay, but a rectangle is not always a square, a rhombus is not always a square. So if you kind of work backwards, it's a nice way for you to look at how they are connected. Alyssa? We're going to get to that today. We're going to talk about kite today. Yeah, very, very good point. This is kind of like a thing to get you guys thinking about the kite because we haven't talked much about it. We're also going to talk more about the trapezoid and parallelogram today. So we're not done talking about the little details that they each have. Matt? Okay. Oh, okay. Well, now are you with us? Like all the lines? Okay. Annalise? Well, it just tells you everything on this chart has 4 sides. Quadrilaterals at the quadrilaterals at the top because everything on here has 4 sides. A rhombus has all 4 congruent sides. A parallelogram does not. Okay? No. No. A square is always a rhombus. We talked about this yesterday. A square has 4 right angles and all congruent sides. A rhombus has all congruent sides, opposite sides parallel, but the angles are not 90 degrees. A square is always a rhombus. A rhombus is sometimes a square. Okay? Mary? Yes. I'm getting there. That's what Alyssa asked. We're gonna talk more about that today if I get there. Zach? Okay. I'm okay with that for now, but in geometry and in this book, we're going to use it as a kite. You okay? Okay. Do you have a bloody nose?
No.
Okay. Okay, sorry. So Zach, anyway, my point is it's okay for now, but the technical word is kite that you should be using. Okay. Jeremy, do you need to go? Okay. Go to the nurse, please. Okay. You okay by yourself, or do you want someone to go with you? Okay. He's okay. His face is just really white. All right, let's go to the other one. All the way by the gym. Okay, so this one, I think this one's easier. Okay, so Doug, let's start here. What goes here? Okay, good. Okay, shh, 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 shh. Let's raise hands, okay? Circle. We know it's not a polygon, but put a circle. Okay, Charles, what goes here? Nope, this should be closed figure. The word, I'm getting there. Closed figure. Let's go here next, Mary. Good. Okay, good, thank you. Here, polygon. Okay, so a circle is not a polygon, so a circle's first. Closed figures next because all polygons have to be closed. So then that points to polygon. And let's actually go backwards here. So let's start with this one. Okay, Justin, what is this? Good, decagon because there's 10 sides. Briar, what is this? Good, nonagon because there's 9 sides. Okay, Emma M, what's this? Good, octagon because there's 8 sides. Matt, what's this? Good. Let me just find it. Septagon, heptagon, I put both of them up here. No. That's only for anything more than 12. Okay, Donatus, what's this? Good. Mary, what's this? Perfect. Okay, and then our last two, Emma H. Hey, I lost one. Oh, no, I didn't. Good, quadrilateral, 4 sides, and then lastly a triangle. Annalise? Well, I would put quadrilateral because anything with 4 sides could go there.
So, like, closed figure, I just had, I think I put quadrilateral, but not sure.
Well, that's not a quadrilateral because there's curved edges. So you guys wouldn't have known to put closed figure up there, so that's why I'm telling you. That should be closed figure because all polygons are closed. Mary? Well, I mean, I guess, yeah, but that's supposed to just be a random thing so that we know that, here's a polygon. We know by definition now what a polygon is. Here's all different types. Sure. Okay, Doug, question? This is a question? What do you mean, what classifies a polygon? Okay, who can answer that? We went over this in lesson 1. Briar. Good. No round edges, everything's closed. And, Justin? Good. The lines intersect only at the actual vertices or the edges. Doug, did you remember that? Okay, that's back from lesson 10.1 if you need to look back in your notes. All right, so these are very important to hold on to. It helps you with the classification. Okay, so we'll refer back to these at times. Just make sure you keep those handy. If you would like to take them out of your homework packet and put them into your note packet of your binder, like into that part, you can. That's completely up to you. Okay, I need you to open up your note packet to page, actually, I don't even know what page. I think it might be page 6 in yours. Lesson 10.3a. Hold on, let me see. Page 5. Okay, here we go again. My pages are different. So page 5. So I am going to literally fly through some of this because guess what? Some of this talks about area of a rectangle, area of a square. Very boring, very easy. We've done it before, okay? However, I need to give you the formula again to make sure we're all on the same page. But I'm literally going to go pretty fast through this. Stay with me. Like not like fly, but faster than usual. All right, Charles, how do you find area of a rectangle? Good. Sean, how do you find area of a square? That's okay. I'm just calling them.
Side times side.
Good. Side times side, which we typically write as side squared. They all have the same sides. Mary, area of a triangle. Good. And some of you guys prefer base times height divided by 2. So write down for area of a triangle what you prefer. Whether it's 1/2 base times height, just put it on my desk if you're done. Or base times height divided by 2. So either one, you guys can obviously use whatever you prefer. Okay, now we've done these before in chapter 1. We've already talked about all of these. Annalise? Yeah, but all the sides are the same, so that's why we write it like that. Okay, flip over to the next page. All right, I told you, this is going to be quick. Easy. I don't know why they had this again. I'm going to shut these off so we can see. All right, so let's look at letter A. Zach, what kind of figure is letter A? Good. I want you guys to put rectangle. Donatus, how do we find the area? Good. Length times width. Okay, who can tell us the area? Again, we're going to be speedy. If it's too fast, just tell me. Matt? Awesome. 44 centimeters squared. Very important that you have your units squared, so don't forget about that. Everyone with me? Is it too fast? Okay. Mary, is this a question? Okay, well, Mary, first of all, the next one, what kind of figure is it? Okay, good. Charles, how do we find area of a square? Good. So, Mary, how do we actually find the area? Good. What kind of feet? Good. Questions on that? Okay, let me go to let's go to letter F. Ooh, I forgot about perimeter. Whoops, hold on. Go back to letter A. Sorry. I should read directions. I'm trying to go too fast. I forgot to read directions. Okay, sorry. Letter A. How do we find the perimeter of the rectangle? So we're kind of going backwards here. Alyssa? Good. Good. So 5.5 times 2 plus 8 times 2. Okay, so Annalise, what do we get? Good. 27 regular units here, centimeters. For what one? Well, we're not there. We're not doing that one. So don't worry about that. Okay, letter B. And we need to find the perimeter because I forgot about it. How do we find perimeter on letter B? Justin, how do we do that? Good. So 6.5 times 4. So what's our perimeter, Charles, in letter B? No. 26. No. Letter B. Feet. That makes a big difference. I don't want you building something for me if you're going to mix those up, right? Okay. Questions on A or B now that I have perimeter on there? Annalise? We're not there yet. We're going to do that one right now. Okay. So letter F, there's something that I have to show you on this one. Because since I skipped 9 before I did this chapter, there's one thing I have to show you. Before I show you that, though, let's find the area first. So area is base times height divided by 2, or 1/2 base times height. Just so I can make sure, raise your hand if you like this formula better. 1, 2, 3, 4, 5. Okay, raise your hand if you like this formula better. Okay, so I guess most of you like this one. So base times height, we have 2 times 1.5 divided by 2. So multiply those and then divide by 2. Either way, what do we get for the area? Briar? What kind of meters? Meters squared. You could also have 3 over 2. So that's area. What's the problem with perimeter? What's the problem, Alyssa? We're missing this. What is this called? Some of you guys might already know this. Sean, what's that called? The hypotenuse. Anyone know how to find the hypotenuse? In chapter 9, we're doing a lot of this, but I skipped it for now. Annalise? Yeah, we're going to make an equation, but there's a name to it. Adam? Good. Nice try pronouncing it. Pythagorean theorem. So here's what I'm going to do. I'm going to tell you what Pythagorean theorem is. We're going to prove it together in chapter 9 so you can see how it works. But now just take my word for to find the hypotenuse, okay? This is a leg and this is a leg. So Pythagorean theorem is a squared plus b squared equals c squared. There's a proof for it. I will show you when we go back to chapter 9. Okay, you might have seen it before. Guy named Pythagoras figured this out. Okay, so let's find the hypotenuse first. So we have 2 squared plus 1.5 squared equals c squared. Okay, we are squaring each of them. So we get 4 plus 2.25 equals c squared. 6.25 equals c squared. I'm going fast because you guys all know how to solve an equation. How do you undo the square? How do we undo the square, Donatus? Take the square root. What is c? Sean? Awesome. Yes, you are responsible for knowing that. Just like this, though. You won't have to go further than finding the hypotenuse. A squared plus b squared equals c squared. Now that you have c for your perimeter, all we're doing is taking 2 plus 1.5 plus 2.5. So what's the perimeter? Doug? Good. 6 what? Good. How'd I get what, Mary? Second square root, so hit your calculator, second x squared. We've done this before. Second x squared, and then type in 6.25, enter. And you get 2.5. Did you get it? The reason I went fast on is we've done square roots before. I just wanted to show you if you have a right triangle to find the hypotenuse, you're just using a squared plus b squared equals c squared. Yes, there's more to it. I will get to it in chapter 9, I promise. That was the hardest triangle one, so any questions on that one? Doug? No, no, because I need to do one more thing. You can ask later. I know, that's why I said you can ask later. Only the ones we're doing. Okay, flip over to the next page of your notes. Okay, and go to where it's the box that says area of page 7, where it says area of a parallelogram. How do you find area of a parallelogram? Annalise? Good. Area equals base times height. I agree. Very easy. Just like rectangle. Okay, so area of a trapezoid you've done before, but it's probably been a while. Are you going home? Okay. Okay. So how do we find area of a trapezoid? Anyone remember or have an idea? Thank you. No? Wow. I'm surprised. Charles, you have an idea? Kind of. Kind of. Alyssa? Okay, you're close. But there's something else. Sean? Donatus? It doesn't matter. Okay, so here we go. 1/2 times base 1 plus base 2 times the height. You may also do base 1 plus base 2 times height divided by 2 if you prefer that. It's the same thing as multiplying by 0.5 if you're dividing by 2. So, I don't know, for me, I always do half of the height first. So I usually multiply these first, and then I add the bases and multiply all that together. We're going to do some of these together right now, but it's up to you the order that you prefer to do that, just like the area of the triangle formula. Alyssa? I'm going to show you. You don't have to, but you could. So, excuse me, let me start with, on the next page of your notes, we're going to start with an easy one. Cross off where it says and perimeter. We're just going to find the area here. Okay, I promise I'm reading directions now. So in the first one, Adam, what kind of figure is this? Good, parallelogram. Okay, so Zach, how do we find area of a parallelogram? Good, base times height. Briar, what are we multiplying together? Good. What's the area? You guys keeping up with me? I'm just kidding. Too early for this, huh? Mary? Good job. You guys are all finding this pretty easy, right? Okay, just making sure. The only thing that's kind of new, I think, is Pythagorean's theorem so far. So, Doug, do you have a question?
Yes.
On the first one that we just did? Okay, go ahead. Who can answer that? There's a lot of differences, but what's one difference, Adam? Good. Good. Parallelogram, both opposite sides are parallel. Trapezoid, there's only one set of parallel sides. Plus, the trapezoid has two different bases, base 1, base 2. Okay, so let's do one more. Let's do one more together. So, okay, let me start it, though. If you already did the second one, good, but let me go through it so I can at least explain it to those of you that need to be explained to. 2 is a trapezoid, okay? So area is equal to 1/2, or you can divide by 2. It's up to you. I just like the whole multiply by half better. Base 1, what, Doug? We're not finding perimeter, Doug. Remember, we crossed it off. I just explained that like 3 minutes ago. Okay, listen. Times the height, which is 12. Okay? So I would say add your 8 and 18 first. You get 26. Now, what I typically do next is I take half of 12. I just think it's easier. Okay, and get 6 times 26. You can also type into your calculator 0.5 times 26 times 12. There's many ways to do it. Again, I prefer just doing mental math. Half of 12 is 6, and then 6 times 26, Mary, is? Good. So when you get down to the whole details of solving, that is completely up to you how you want to solve. Jeremy. Yeah, but there's no reason to do that when all you're doing is multiplying base times height. It's already so easy, don't complicate it. We could do that, but I don't know, in my mind it's just easier, just take base times height. Yeah, and you can do that if you want. That's completely up to you. Did you say you don't? I know you weren't here most of the class. Okay, but you also need to get caught up with what we did since you weren't here. Okay? Yeah, you can do that. Mary? Yes. You're way ahead of me. Good job. Okay, any questions on what we did? Give me a, Sean, go ahead. Sure. Give me a thumbs up, thumbs up, thumbs down on all the area stuff that we did today. Okay, I have one question for you as a closure. Doug, you're not paying attention again. Everyone has thumbs up, thumbs middle, thumbs down. What are you doing? Okay. So who can remind me what Pythagorean's theorem is? Just want to make sure. What is the formula, Justin? Good. When can you use Pythagorean's theorem? When can you use it, Alyssa? Good. Define the hypotenuse of what kind of triangle? Briar? Good. It has to be a right triangle. You can use it to find the hypotenuse. Now, do you think you could use it to find something else? Like, what if the triangle looked like this? And this was a 2 and this was a 4, but we don't have B. Could you use it to find that? Yeah. Well, I'll show you more of that tomorrow. For now, we use it just to find hypotenuse, but you can use it to find any of the sides. It would just be set up a little bit differently. Matt? No, so it would still be a squared plus b squared equals c squared. It's still the same formula. Hey, shh. Well, wait. What did I mess up? Whoops. That's a 2. That's because I made it up and I didn't make it up correctly. I was trying to prove a point, not thinking through the whole solving part of this. Yeah, it would be imaginary, which is not correct. The reason I put this up here, though, is just to show you that if you did get down to this and it would work, let's just say this was a 24, I'm making this up, you would subtract 16 from both sides and then square root both sides. Same thing. You guys know how to solve equations. The majority of you are very good at it, so it's not going to be much different. All right, homework. I'm a little bit late again with you guys, sorry. Okay, practice 10.3. Okay, you're going to do all, which are numbers 1 through 15. I will warn you, numbers 14 and 15 are going to make you think. However, I want all of you to come in here with an answer with them tomorrow. Do not leave them blank and tell me I did not know what to do. That's not true. You can at least start them. Tomorrow we're going to talk about circles if this homework goes okay. What'd you say? No. All right. Are we good? Good job today. Go ahead and get packed up.